Alright everybody, I want to look at one of these static equilibrium scenarios. So I've got a scenario with a sine. I've got parts A and B, but I'm just going to talk about A while I do B, but I'm going to do part B. This one just because I don't want to take too long to do this. So I've drawn the free body diagram. There's my weight. I'm going to take that angle. I don't want that angle. So I've got a cable going this way and a cable going this way. And we know that we have to break it into its parts. Anything at an angle, just the rule of thumb is break it into its parts. So I've got fx, that's fx1 over here. So grab this. I break that into its x and y. Remember, this is always a right angle triangle. I break this one. That's my y1. So I'll bring this over here. You're not coming over quite the order that I want, but that's all right. So I've drawn it all out. So I've broken it into these two parts. And if I look at it, these two have to be equal. Remember we said these two are going to be equal. If they're not, it'll move. And then this side has an angle of 30 degrees. So if you do your basic trigonometry, you'll see this side, if I figured it out, would be smaller than this side over here. So the bigger the angle, the more force it has to hold in the y direction. And as a result, if I do Pythagoras, then because this Fy1 is bigger than this one, then F1 has to be bigger than F2. But this is my setup. So just using that, we don't have to do this step, but I'm going to do it from here. So F net in the y direction equals all the forces up plus minus all the forces down. So Fy1 plus Fy2 minus the weight. And we said that is 0. So I rearranged it so that the weight equals Fy1 plus Fy2. So at this point, if we had equal angles, this would be easy because these two numbers are equal to each other. So we would just replace Fy2 with Fy1. We'd have two Fy1s and we could solve it. But they're not equal to each other. So Fy1 does not equal Fy2. So what do we do here? We have to come up with some kind of relationship. So if I look at it, I know I do know that Fx1 equals Fx2. And Fy over Fx equals the tan of theta. So what I'm going to do is I'm going to say that Fy equals Fx tan of theta. So I'll take that idea up here and I'm going to replace the Fy1 with Fx1 tan of theta and Fy2 with Fx2 tan of theta. And I know the Fx1 Fx2 are equal, so I'm going to change this to Fx1. Now I need to show these. You need to show these where these steps came from. You can't just skip to the third or fourth line in these ones because you're making substitutions. So if someone's following your work, they'll be like, where did this come from? So I need to have this over here. So then what I've done is replace Fx2. Now I have a common factor of, and these should be thetas, not O's. I guess I never went and fixed that before. So I've combined, I've taken the like term out, and I've got Fx1 and I've got tan of theta 1 and tan of theta 2. At this point, put the 45 and the 30 in. I take the tan of 45 and the tan of 30 in my calculator, add them together, divide them to the other side, and I get Fx1 equals 380.38. So that's what these values are. 380.38. Both sides. But we don't care what we do. Well, we don't really have to worry about that. What we want to know is what is Fy1 or F1 and F2. So knowing that, move my box out of the way, Fx1 over F1 equals cos of theta. Of course, I'm missing a C. Cos of theta. So 380.38. And I'm just going to, these two are just going to flip spots. Remember back the unknowns there. So divided by cos of 45 equals F1. Repeat the same process over here for F2. I'm not going to write it down. I'm just going to tell you what the answers are. When I do the math for that, I should find F1 is equal to around 537.94 newtons. And F2, because I would be doing divided by cos 30, which gives you a bigger value to divide by, I get 439.22 newtons. And we said that F1 would be bigger because the Fy1 was bigger than the Fy2. So these would be the forces in each of those cables. Now, what I've got you here, I'll show you one other thing. If you look this up online, You'll also find sometimes they do it a little bit differently. So they get this point, they have fy1 plus fy2 equals w, and then they say f1 sine theta 1 plus f2 sine theta 2 equals weight, which is what we could do. And then they look for a relationship between f1 and f2. So they say fx1 equals fx2. So f1 cos theta equals f2 cos theta. They're equal to each other. And f1 would equal f2 cos theta 2 over, sorry, that's a little bit ugly, over cos theta 1. You can put the values in and find a ratio. So f1 equals f2 times by some number. Or you could substitute them right in. So f1 is going to be replaced with f2 cos theta 2 over cos theta 1 times sine theta 1. I know it's getting a little bit crazy looking. Plus sine theta 2 equals w. Now, I like the tan theta method, but this way works well too. I can put all my numbers in, so I can put these values in. You can go one step further. You can do it this way if you want. This would be cos theta 2 tan theta 1 because of these two together, plus f2 sine theta 2 equals w. Now the beauty of this method, I put all my numbers in, gather up my f2's, so I would get f2 and then the like term of cos theta 1 tan theta 1 plus sine theta 2 equals w. The beauty of this is when I get it all done, I'm straight to f2 and I don't have to then go do the divided by the cosine like I did in the last example. I can just take the value and then I can plug it in up here with these values and find f1. So either of these methods will work, depends on what you like. But if you either find a ratio between them and substitute it in, or do this method. Either one will work, either one will get the answer, and they'll work for unequal angles or equal angles. So I can put in the 45 of both these and get my value here, which would be 300 in that case. And then I still have to divide by sine to get the fy1 back. But either way will work. I hope that makes sense. A little bit long video, but that should explain all of the stuff for these type of questions. Thanks.